Hello, welcome to Mathy Python. Today I will look at the solutions to the puzzles and problems for episode 5. As usual, there are 3 tiers, warm-up, intermediate, challenge. Problem 1 says given a string, extract a substring from it using slicing. So S is the string, then the substring, I will slice from it. So this says use that string, look at an index, the beginning index, the end index. So these start at 0, so that's 0, 1, 2, 3, 4, 5. So 6 is the P. To go to the end, I could count it out and put that in there. If you leave it blank, then by default, it goes to the end of the string. Problem 2, write a one-liner that takes any string and returns it in title case with leading and trailing white space removed. Test it on the string that has a bunch of spaces in all lowercase. So again, S is my string. Strip will remove all the spaces from the beginning and the end and leave the ones in the middle of the string intact. So if you just want to strip off the space from the left and the right side, there are also L strip and R strip for left and right if you need that. Title makes a title case, which will uppercase things as you see in titles. There it is. Number 3, how many times does the letter T appear in Mathy Python? Use the string method, not manual counting. Right, so the method here is count. So S is Mathy Python, then S, count. What do you want to count? T, and then print it out. So it occurs twice. Number 4, without running it first, predict what the following code prints, then check it by actually running the code. So the first line, S equals Mathy Python, print S sub 0. It starts at 0 again, so that's capital M. -1 goes to the end, so that will be the N at the end of the string. Print, this is start, end, and step. So this will do every other. It will start from the beginning and do every other letter. So M, then T, then Y, skip the space, P, I believe, yeah. Then T, then O. And a useful trick, if you put -1 for the step, it just reverses the string. This is a very easy way to reverse a string. So it just prints out Mathy Python in reverse. Let's see if that's correct. And it is. Number 5, use an F string, formatted string to print the following using variables for each value. So the area of a circle with radius value is value. So I give names, variable names to the values 7 and 153.94, and then just print it out. The area of circle with radius is area. I could have calculated the area too with a formula. Here 2, intermediate. Given a full name as a single string, extract first name and the last name in the separate variables using the string method and print them in reverse order, meaning last name first, comma, then the first name. So the name is Mark Pettigo. In my case, you would use your name. First and last names is name.split. I'm going to print that out just so you can see what's going on here. So that will split the string by default on the case, but you can, if it's, for instance, the CSV file, you can split on the comma or on a semicolon or whatever it is you want you use to delimit words. So in this case, it's just some text that has a space between first and second name. And so I could actually specifically tell it a space. Comes out the same by default. If you leave it blank, it'll split on the space. And what it does is that it creates a list that has those words in a list. Then you can manipulate the list. You can do whatever. Many times you'll then want to turn it back into another string like we are here. Then the name reversed will be this first last name. The last name was at index 1, 0, 1. Then a comma, then the first last name 0, and then you print it reverse. Number 7, a user enters a number as a string. Write code that checks whether the string represents a valid integer before converting it. So look up the string is digit method using help or the question. So is digit returns true if the string is a digit string, false otherwise. You can also look at the online documentation. I put a link for that. So this is from Python.org version 3, and then it goes through. There's lots of documentation up there. Very useful. Okay. So the user enters a number as a string. So that's input, enter a positive number. If it is a digit, then I cast it to an integer. I know that's safe because it's a digit, and then print it. Otherwise, I'll say that's not a number. So enter a positive number, 34. There it is. If I run it and I say for the word FOUR, and I run it, that's not a number. Number 8, without using replace, reverse just the first word in Mathy Python. And the result should be this. Again, I use split. I'll print out words too, so you can see what's going on here. Okay, so S is Mathy Python, words is s.split. That means that it is this list. Then word sub 0, this first word, I'm going to replace that with that same word. 0 here is the index. And then the second brackets tell the slicing. So I'm going to use slicing to reverse it. And then let's see. Let's print words again. So we can see, yeah. And it did it. So it took the first word and replaced it with that word reversed. The result then joins these. It joins all the strings of the list, but you need something in between them. You need that space back in there. So this first part tells you what to put between the words. So join words, puts them together, concatenates them into one big string. Between the words, what do you want? You want a space. Number 9, given the string, so this is some sort of data, looks like grades, scores and grades. So Alice got a 92, that's an A. Bob got a 75, that's a C. Carol got an 88, which is a B. So it looks like each record is delimited by a semicolon. So the fields are delimited by spaces, but the lines are delimited by semicolons. Okay. So let's split this into individual records and split each record into fields, print each student's name and score on its own line. So our output looks like this: Alice 92A, Bob 75C, Carol 88B. So this is our data. I just copy pasted that. Records is the data split. Okay, so you can see that that's split on the semicolon. So that results in a list. The first entry is Alice 92A with commas. The second entry is Bob 75C, Carol 88B, with commas between the fields there. So to get the fields, I will split for each one of these records. So I'll step through it. The first record will be Alice 92A. The second one is Bob. The third one is Carol. And then I will split these again, this time on the comma. As in the last problem, I join those fields, put a space in between them, and then print them. Let me clean this up. And it looks like that. Number 10, format the output of problem 9 into a table. Look up string formatting, and I give you a link. This might be worth bookmarking to refer back to how f-strings format. Okay, so the data, then I have the records. I print the header, so the name that takes up 10 spaces. The score that takes up 10 places. The grade that takes up 10 places somewhere on the end, so it doesn't really matter. Then I step through the records. I split them like I did before, split it in the name, score, grade. Then I print name using 10 spaces, score using 10 places, and grade using 10 places. Tier 3 is palindrome checker, meaning is the word the same frontwise and, where's my camera? Frontwise and backwards. So right coded checks whether the string is palindrome, reads the same forwards and backwards, ignoring spaces in case. Tested on race car, a man in Canal, Panama, and Mathy Python. So I wrote a little function here. That's is palindrome, takes S, presumably a string. And then, first of all, I replace a space with a not space, just a null. So that gets rid of characters, not just on the left and right ends like we did before with strip, but all of the spaces will be replaced, including the ones in the middle of the string. And then I will change that into lowercase. One cool thing here, I can daisy chain. That's what we call this. I can daisy chain methods. So replace and then lower, and just daisy chain those methods together. And then I check to see if the string is equal to the string reversed. And check it on these 3 test cases. So race car is the same backwards and forwards. A man in Planet Canal, Panama, once you get rid of the spaces in the lowercase, is also a palindrome. Mathy Python is. Caesar cipher decrypted. You receive an encrypted message, encrypted with a Caesar cipher using the shift of 3. So A goes to B, C, D. Actually, the other way around. D goes to C, B, A. 3 letters before it. That's what a Caesar cipher means. To decrypt a loop over each character, shifted back by 3. That's what I just said. Modulo 26. So if you have an A, it will wrap back around to the end of the alphabet, Z, Y, X. That's what that remainder, take the remainder 26. That's what that does. And rebuild the string. Preserve spaces and punctuation. What does it say? So I wrote a function here, decrypt message, the alphabet upper, alphabet lower, all of that. I use uppercase for the variable names to indicate that these are constants, meaning that once they're defined, you shouldn't change them. That's not enforced by Python, but it is a convention that if that's your intention, you write the variable name in uppercase. Then I build the result as initially empty for the character and message. So I'm going to step through every character in my message here. If the character is in the alphabet upper, then the position is the index of that character, whatever it is. If it's a P, for instance, it'll go back 3. Which is what the new position does. The index grabs wherever it is in the string here. The new position backs it up by 3. A will wrap around back to Z, Y, X. That's what the mod 26 does. And then the new character is the alphabet upper of that position. Same thing in the lower. Otherwise, I just leave the character alone. So I say the new character is the old character. Tack it on to the end of result. Go through the whole string, do this, return that. And it says Mathy Python is fun. Word frequency, given any sentence string, count how many times each unique word appears. Ignoring the case and punctuation, print the results, test on a sentence of your choice. For my sentence, I said how much wood would a woodchuck chuck if a woodchuck could chuck wood. Then for the sentence, change it to lowercase, replace a question with just get rid of the question mark. That's the only thing I have to deal with in this particular string. Is writing a more robust program, we need to check for commas and periods. And okay, I didn't do all of that, but if you want to make it more robust, then you would. Here we go again with the split. So that changes the sentence into a list of words. Then I will change that list of words into a set that dedupes it, that takes out all the duplicates. Create an empty dictionary, which I will now build up. So for the words in the unique words, if the word is not already in the dictionary, then I add it to the dictionary. So words of dictionary of that word equals count how many times that word is in there. And then print it out. So we see that wood appears twice, chuck twice, how once, much once, so forth. If you want to sort by frequency, we haven't covered this, and it looks a little odd if you haven't seen it. So in lines 16 through 18 really, 2 comments. The way you do this is sorted, whatever you want to sort. The key is words dictionary.get that tells it how to get the key. And then you reverse it true so that it's ascending rather than descending, and then print it out. We'll get into more of this kind of stuff in the intermediate series. If it doesn't make sense right now, don't worry about it too much. Okay, so that is the solutions for episode 5. If you have any further questions on it, please leave your question in the comments. Yep, and I hope to see you in the next episode. Happy programming.